Our next guest invites us to take part in their journey where they created a data mesh from scratch. Well, that's interesting. Facing several challenges from no data literacy, no data governance, no data strategy, they created a true and single point of information in a data lake where all the data respects the data mesh rules, making it very easy for anyone to access their data anytime. Please welcome me in joining Alexandru Craciun, Head of Data Engineering at EPAM Romania. He likes to help people reach their maximum potential and lead them to the big data world. And today he's going to share our expertise with us. Please.
Hello everyone. Thank you for a kind introduction. I'm glad to be here and present to you one of our greatest projects, to be honest. But before that, let's talk a little bit about us. As I said, I'm Alexandru Craciun. Currently, I am Software Engineering Manager at EPAM Romania. I'm covering 4 separate areas: data engineering, integration, DevOps, and architecture. At the beginning of my journey, I started as a big data developer. After 1.5 years, I had the opportunity to be the team lead of the big data team. And after a few more years, I got again the opportunity to be the team manager. To give a little bit of context about EPAM, we work on very big projects with niche companies, and we are very dreamy, and we like to improve everything we are touching. There are more than 60,000 employees all around the world in different regions and countries. Almost 10% of this percentage, of this number, are working in the data analysis unit, and we like to increase this number even more. Even in Romania, we are hiring a lot in this department because we think this department and this unit is very, very important for every company. This month, we started our data engineering mentoring program, where we are looking for persons to learn about big data. This mentoring program is split into phases. In the first one, we are going to provide to you some basics about big data in video tutorials and also text. And on the end of this phase, we are going to give you a test, and if you pass that test, you are going to go into the second one. In the phase 2, you are going to have a special mentor dedicated for you, and also you are going to work on our custom platform, where you are going to learn together with that mentor on real-life scenarios and projects, everything about Spark, Hadoop, Kafka, and cloud, and much more. That being said, if you have friends or you want to join in our program, please come to our booth to find out more details. But enough with the boring stuff, because we are not here for this. Knowing that this presentation will be the last one before the lunch, I thought that would be nice to have a light talk and a little contest where the top 3 competitors will get a prize. To participate at this contest, you have to access menti.com on your device, and you need to fill the code input with the code that is shown in this slide. When the time comes, you are going to get a pop-up, and you have to answer to that question, which is related to a previous technology that we talked about. That being said, let's take a look at our agenda and see what we're going to talk about. It's not a big agenda, to be honest. Today, we are going to talk about our journey on creating from scratch a simple, scalable, and most important, reliable data mesh. We'll see where we started from, what was the initial mess we found, what were our challenges, and how we successfully delivered this story. So, our goals were to create a solution that can be quick and easy to scale, and and a data strategy also. And the other part is that we had to learn the business people that data is a very important fact, and they need to rely on data when they take their decision. To do this, we started a series of meetings with them, and we started to show them and exemplify them with real life numbers and scenarios, what we did with previous companies, and what was the output. During those meetings, we found out that some of them had previous Power BI knowledge, but before, but let's take this in consideration, and we'll see later why this helped us. In one of those meetings, one of my colleagues had a great explanation, which was easily understood by everyone. To be honest, I don't know if he finds this on internet or not, but it's a really good one, and I'm going to show it to you. Let's imagine we are an airline and data is our fuel. That means the strategic plan guides us which type of segments and seat mix will fly. Data mesh, it's our approach for procuring planes and fuel. Data literacy is training for our pilots. And data strategy ensures we get the right combination of planes, fuel, and pilots. Well, I think we need to test right now if Menti.com works. Let's see what's the first question. What's the first phase of the project management lifecycle? I know I promised to you the next ones will be technical. I'll give you 30 seconds. So everybody answered? I got a sign that they don't. Okay, everybody answered. Sorry about this. I didn't tell the organizers that we needed an internet connection, so my research manager is here, he's helping me. So here the answer is initiation. In the initiation phase, we identify our business needs and our problems, and we brainstorm ways of solving that problem. Well, to achieve our project goals, at the beginning we had to assess the mess. After the analysis period, we found out that the company didn't have any knowledge how to handle data. Maybe you are asking yourself, what does it mean that the company doesn't know how to handle data? Well, here is not a straightforward answer. But in our case, we found out that they had over 40 internal applications with lots of data duplicated between them without any good reasons. There weren't any guidelines to check if data exists in other application if you need it, or how to take that data if you need it. There are many cases when the same KPI had different meanings, even though their name was the same. Looking at those type of scenarios, we saw that both business and developers got frustrated because of this. Because one of them had to wait longer for his expected result, and the other one had to redo his work. And we know how developers act when they need to redo their work. Another thing that we found out is the fact they didn't have any conventions, even though they used the same technologies over and over again in those 40 applications. We also found out that business used a lot of Excel files to create their reports, or even worse, to store their own historical data. I think here every good company does this. So, regarding the last problem, I found a good meme on the internet, and maybe you're going to enjoy it. Now, maybe you are thinking that we found out only bad things, but it's not the case here. We found out that those 40 applications were created to serve a specific part of the domain of the business. Even though there were some connections and interactions between them, we could have used this in our advantage. Based on this, we thought that domain-driven design can be applied here. This gave us the start point. We are going to start with the core of our data mesh and implement every domain one by one until we are going to cover it all of them. Knowing from where we began, let's take a look on what and how we implemented. So I think here's the interesting part. Here's a big picture of our architecture. It's a little bit abstracted, but later we are going to break it down in two parts and to show you guys the technologies we used and also some reasons behind those decisions. But before that, there you can see that the core of our data mesh, it's the event broker, which means that we used Kappa architecture. Now, let's have a short overview on what's Kappa architecture. The main premise behind Kappa architecture is that you can perform both real-time and batch processing with a single technology stack. Thank you. Also, it is based on streaming architecture, in which an incoming series of data are firstly stored into a messaging engine. From there, a processing engine will take it, will read it, will transform it, and after that will store it into an analytics database where the power users can query and also to create reports and dashboards. Having in mind the entire design, let's take a look at the technologies we used and also the reasons behind them. So here, as you can see, this is the first part of architecture where we're extracting the data from the sources. In our case, there were some custom applications from where we had to pull the data, some third-party applications like you can see, and also third-party systems, which was a little bit harder for us, but we managed to do it. To pull the data from our system and from our application, we chose to use Workato for its capabilities to easily integrate and create fast connections between applications like Salesforce, Jira, or platforms and storages like Amazon S3 and BigQuery. To store the data, we took the decision to use Kafka Confluent. There are multiple reasons why we chose to use Kafka, but mainly because we needed a reliable solution that can easily scale, and also we needed the capability to process the data in real time and batch for analytical purposes. Now, maybe you are asking yourself why we chose to use Confluent version of the Kafka and not Apache one. Well, mainly because we didn't have any time and we couldn't afford any maintenance overhead. If any problem would have occurred there, we had to lose a lot of time to repair those bugs on the DevOps side, and we couldn't afford that. The second reason is that if we don't need Confluence anymore, because we are not using any other features but just the base platform, we can easily drop it. But this will bring us manpower costs and overhead, as I said earlier. But in the end, the final user will not see anything. Nowadays, technologies are changing with fast paces, and we must keep in mind this. By having a simple design and pick the tools that can be easily changed and maintained, you can do your future work easier. Now that we talked a little bit about technologies, I'm coming to you with another question, which this time it's a technical one. What are the different elements or components available in Apache Kafka? So, thank you. So, I'm seeing that everybody answered. The right answer is all of the above. Now, it's time to look at one of our domain architecture. Here, here it is. It's simple, as I said, like this talk has his title even. For our first integrated domain, we had to decide which processing engine we should use and also how to store the data so that it should be easy to be accessed by applications or by power users to create their dashboards and reports. The development team had previous knowledge about Looker, but after those meetings that I talked earlier, they found out that power users had previous Power BI knowledge. By taking this into consideration, we started our quest to find technologies for processing and also for the storing part. To respect the Kappa architecture, we had to choose a technology that can do both real-time processing and batch processing. Here, our decision was split between technologies like Flink or Spark. After long debates between architects and developers with cons and pros list, we decided to pick Spark. We took this decision because Spark has advanced analytics capabilities, it integrates with many tools and technologies if needed, and it has fast performances because of its in-memory structure. We chose to use Databricks as a self-managed platform to eliminate a big part of our overhead maintenance. As I said earlier, we try on every step to reduce maintenance overhead. By picking Databricks as our processing and platform, we had the option to use Delta Lake tables, and looking at its capabilities, we saw that it fits our needs. The features we liked the most was the fact that data lake tables had a seed transactions. It gave us the possibility to roll back everything if needed and also to time travel. Now, talking about technologies, I think you already know what is going to happen on the next slide. Pick the available cluster manager for Apache Spark. Tough one. If you want to be mad at me, I'm going to let you know the questions I picked were from a list of interview questions, the top 4 or something like that. But I scrambled up a little bit the options. So everything okay? Let's see the correct one. The correct one is B, Kubernetes. Now, let's take a look if we are putting together both parts. The part where we are pulling the events from our application and systems, and the part from the domain side. Let's make a short overview. We are pulling data using Orcato. We are storing them using Kafka Confluent, processing them with Spark on Databricks, storing them into Delta Lake, and serving them through Power BI and custom applications. Until now, we covered the pulling part of the job, how to process it, and how to store it. But in my opinion, to have a healthy data mesh, we need something to assure that the rules are followed. In the first picture of the architecture, maybe you are remembering that you saw a purple square with schema handler tag on it, which is also present here. The schema handler is an application that we built to keep our data layer healthy. This solution will communicate with all the services and applications to enforce, validate, notify about schema changes. It also allows to plan schema changes and notify all the other applications that are using your data regarding the changes you are making. This solution isn't bulletproof, but it handles almost 90% of our scenarios. And we are still working on developing this solution. For the core of data mesh and the first domain, we decided to use as a platform Azure. From it, we are using lots of tools, but the ones that are in focus right now are Azure DevOps to deploy our solution together with GitHub, and also cost management because we don't want to make the business people angry. For discovery and data governance, we chose to use Azure Purview, which gave us the ability to view and manage health metrics, and also to view the entire data estate. Azure Purview has many other features, and if you are using Azure as a platform, I advise you to take a look at it and its capabilities. Well, this is our entire architecture, and I think it's time to ask you another question. Pick the correct features of Delta Lake. My assistant is very lazy, so that's why it's responding to me that hard. It's my resource manager, so he can't fire me yet. Okay, thank you. So the correct one, it's time travel. Even though I would like to see unicorns in real life, they told me that they are not going to implement this feature in Delta Lake because they can't catch on. So I'm saying they finished. I'm going to keep you guys 3 more minutes. Until now, let's go to present. Until now, we integrated 3 business domains, and right now we are working to integrate more. Our current workspace allows us to integrate 1 domain each 3 months. Every time we are integrating a new domain, we are learning new things, and we are improving our schema handler and also our procedures and documentation. Because we wanted to give to our customer flexibility, we have 2 new teams that develops 2 new domain architecture based on AWS and Google Cloud. In both of those scenarios, the main core part of the architecture will be the event broker, which is already developed in Azure. To wrap up everything, keeping things simple can benefit both business and development. In fact, an architect has to take into consideration both sides and to take decisions that can help both of them. I think in the data department, it's not important the amount of tools that are used, but it's more important on how to use it and if it's the right way. So, as you all know, we talked a little about technologies. Let's see our question. This is the final one, I promised you. My assistant stays on telephone. If I will stay on telephone at work, he'll fire me, so I don't think it's fair. Thank you. So, everybody answered? Okay, everybody answered. The correct answer is event broker. So, that's all from me. It was a simple talk and a light talk, actually. I didn't want you to bother with a lot of technologies and a big architecture because it's not needed. You can do good things with simple architectures and less technologies. Now, I'm going to take my phone because I am allowed here and to see who won. At least this time he allows me. So we have number one, a person called Alex. The second one is Marius Grumăzescu, a former colleague of mine. And three, Christina. So we are waiting for you to our booth to have a little talk. I can explain you this better than on stage because, yeah, it's stage. So that's it.
Do you have any questions? Yeah. It's before lunch. No one has any questions. Okay.
Hello. I have one question. I'm curious about event broker. What's the purpose? The purpose is to store the data for a long time or only for a short period?
In some cases, we are storing them only for 24 hours, but there are some cases when we are storing them for months, 6 months or 1 year. Depends on the scenario. As I said, in our case, the event broker was the main storage of us. That one we can control better than the others.
Thanks.
Thank you.
Anyone else? Okay, that being said, thank you.
Thank you very much.
Alexandru.